Hi everyone, this is Vivek. Bitmask DP is often something that I find students fearing of, whereas it's actually one of the most easiest one to learn out of advanced forms that you will ever see in front of you, right? I think most students fear Bitmask or bit manipulation DP because of bit manipulation. Either that's not clear or DP is not clear. But if you understand it in the forms way in which we have learned on our channel on the DP workshop, you will be able to understand DP Bitmask with super ease. In fact, there is a content that I've created around this way long back, and I think it's very, very helpful, which I'll talk about in this particular video. So stay tuned and I'll talk about all the subforms of DP Bitmask that you need to know about, which will enable you to solve almost any problem thrown at you on this topic in different OAs, in interviews or anywhere it comes up, right? Okay. First of all, what is Bitmask DP? It's just DP which has one state as a mask. What is a mask? It is some sort of zeros and ones. It's some sort of ones and zeros that is being stored, which is carrying some sort of information, right? That's called a mask, okay? Maybe a set, which elements are taken or not taken, things like this. Well, DP Bitmask actually has 6 fundamental subforms. And if you practice just one problem of each subform, you will be able to understand how to solve almost any Bitmask DP problem. What are these subforms? First is matching based. So you might have a scenario where you have like bunch of elements over here n, bunch of elements over here m, and you have to match these, okay? So let's say you have to match elements with these over here such that you can maybe drop some elements on one side and take all the elements on other side. Let's, for an example, take this, right? And you will get certain score if A of I and B of J are matched together, right? Things like this. So there is some sort of matching. And in such problems, generally one of these constraints are low. It's like 15 to 10 or things like that, so that we can maintain the set that has already been matched in our mask. So that's called matching based DP Bitmask problems, okay? What's the next form? Graph nodes and cycles. You might have heard about Hamiltonian cycle, right? Find a cycle in the graph such that every node is visited exactly once. To track exactly once property, you have DP Bitmask coming into picture and helping you track which nodes have already been visited. Okay. Next, pairing values. You have bunch of elements, okay? There are 10 values and you have to match these things together, right? So you have to pair these things in different orders, and every pairing will have a score and you have to think about which pairing is the best. Now this is another part which generally uses Bitmask DP, because when you have different nodes or different items, whether they are already paired or not is what you keep track in the DP Bitmask. In general, this is hard because you'd have some sort of like n into n minus 2, n minus 1 into n minus 3 into falling factorials kind of expression for this. And factorials are high in complexity, but 2 to the power n is something that you can manage in such problems, right? Next, you have breaking groups. This is another interesting problem of Bitmask DP, such that, for an example, given a graph, you have to find out minimum number of edges to delete so that the graph becomes a DAG. There is no more cycles, right? This is a very, very interesting property of like DAGs that you can exploit to solve this problem, right? Profile DP. This is another very, very beautiful problem that, let's suppose, given a 12 cross 12, you have to fill this with, let's say, a domino and a triamino of shape like this. How many ways are there to fill it, right? There are problems like this. And profile DP is something that solves such problems where you like basically iterate through, like in DP, we know that in first form, you iterate through every cell and you think about how to fill this. But you need to know whether you can fill this with the domino, or maybe you can put a triamino like this, right? So you need to know whether the previous cell and things were filled when you were filling things like this. So that is why what you do is, when you reach a particular I comma j, you maintain the mask of what has happened in the previous row, or maybe even 2 rows if required, right? So maintaining what has happened, what is empty, what is filled using mask is something called as profile DP. Then you have submask decompositions, wherein, let's suppose, you have a big set and there are a bunch of elements. Instead of pairing them like the third one, you have to break it into smaller groups, and then there are some metrics around these smaller groups by which you will get the answer, right? So these are 6 fundamental subforms of Bitmask DP that like creates new questions. If you solve one problem of each, you should be able to solve almost any problem of Bitmask DP. And believe me, this topic is something that can give you very easy edge over others. It might come as a last question in some contest and you will be able to solve it in a snap. Okay, so that is what you need to do. Now, don't worry if you don't know these forms. I have created dedicated videos and I have structured them in a small course, small free course. So the link to that course will be in the description below. And there I have attached practice problems for each of these problems, each of these forms, so that you can also code it up and check whether you have understood it correctly or not. Once you do that, you will be able to almost solve any Bitmask DP problem thrown at you. So that's just a quick video around Bitmask DP. I hope you enjoyed this. Maybe I'll create another video around some other topic talking about its forms and subforms, but I hope this structured way of frameworks of thinking about problems is something you enjoy watching from me. So that will be all for this one. See you in the next video. Bye-bye.